Okay, hi. So let's continue with some examples of tabular method. Okay. Okay, we have two examples. Right, evaluate the following integrals using the tabular method. Okay, A, we have integrate x squared sine 3x dx, and B, integrate x squared exponent for x dx. But for the second question, we have the limits of integration. Okay, let's start with the first question. Integrate x squared sine 3x dx. Okay, all right. So since this is two functions, okay, we have two different types of function, okay, polynomial and also trigonometric. Okay, again, if you use Lopat, so exponential will comes first. Okay, so for tabular method, we have to put or we need to create two columns at first. Okay, so we have functions to differentiate and functions to integrate. Okay, so if you use Lopat, polynomial will comes first. So we take that function as a function to differentiate. Okay, so we have x squared is function to differentiate and sine 3x as a function to be integrated. Okay, all right. So the process you need to differentiate and integrate until you get x squared. You differentiate that function, you get 0. Okay, so we start with x squared. Okay, x squared you need to differentiate, so you will get what? Differentiate, you will get 2x. Okay, and integrate, so integrate sine 3x. Okay, integrate sine, you will get negative. Remember? Okay, sine will get negative cos, the same angle, which is 3x, and you need to put 1 over 3 in front. Okay, so this is the integration. If you integrate sine 3x, so you will get negative 1 over 3 cos 3x. Okay, you cannot stop this up to this, but you need to differentiate again. Okay, the function. Okay, we have 2x just now. Okay, so differentiate 2x, you will get 2. Okay, and integrate negative 1 over 3 cos. So integrate cos, you will get positive cos, right? Okay, but since you have negative in front, so the negative will maintain. Okay, so cos, you get sine, same angle, but in front you will get 1 over 9 because you get 3 times 3, so you get 9. Okay, alright, so we cannot stop at this iteration, so we need to proceed. Okay, so differentiate 2, you get 0. Okay, integrate negative 1 over 9 sine 3x, so sine integrate, you will get negative, right? So you get positive in front. Okay, negative you get positive, so sine you get cos 3x, and you will have 1 over 27. Okay, so if you proceed, okay, you will have the same formula. Okay, you will get the same answer because differentiate 0, you will get 0. Okay, so now we put the sign. Okay, here, so we will start with positive, negative, positive, and negative. Okay, and you multiply like this. Okay, so we transform it to, so the final answer that you should get is, okay, we have negative 1 over 3x squared cos 3x. Okay, minus this one. Okay, minus, you get plus. Two over 9x sine 3x. And then have plus 2 over 27 cos 3x. And since this is indefinite integral, so we put plus c at the back. Okay, so this is the answer for question A. Alright. Okay, so now let's move to question B. Okay, we have the function x squared exponent for x. Okay, so using the same techniques just now, so I have something to differentiate and something to integrate. Okay, so we have polynomial and exponential. So if you use low pad, okay, polynomial will come first as well. Okay, so I put x squared as function to differentiate and exponent for x is function to differentiate. Okay, alright, so we proceed, we start with x squared, differentiate x squared, you will get 2x. Okay, integrate exponent for x, you get exponent for x, the same powers, okay, but you need to put 1 over 4. Okay, next is to differentiate 2x, that then you get what, this one, 2. Okay, integrate 1 over 4, exponent for x, so you get exponent for x, 1 over 4 times 4, 16. Okay, then we repeat this one, so differentiate 2, you get 0, and this one you get same exponential, the powers of exponential are the same, but we have 1 over 64. Okay, 16 times 4. Okay, so this is the answer for differentiation, differentiate and integrate. Okay, next is we put the sign and we multiply it. Okay, so in front here is the sign. So the answer you will get is what? 1 over 16 x squared exponent 4x. Okay, minus 1 over 8x exponent 4x plus 1 over 32 exponent 4x. And we need to put the limits of integration. Okay, so 1 over 16, okay, 1 exponent 4 minus 1 over 8 times 1 exponent 4 plus 1 over 32 exponent 4. Okay, minus 0 minus 0 plus 1 over 32 exponent 0. Okay, don't forget that exponent 0 is 1. So you'll get the final answer, which is 1 over 16 exponent 4 minus 1 over 8 exponent 4. Okay, plus 1 over 32 exponent 4 minus 1 over 32. Okay, so you can simplify it. Okay, so you can simplify this one, but this is times 2, this is times 4. So 2 minus 4, negative 2. So negative 2 plus 1, we get negative 1. So you have negative 1 over, Okay, negative 1 over 32 exponent 4 minus 1 over 32. So this will be the final answer. Okay, this is the answer for question B. Right? Okay, notes. Consider the following examples for the process when the differentiation does not yield 0. Okay, because some of the functions that you differentiate cannot be 0, right? If you have the combination of something that you cannot 0. Okay, for example, okay, if you have exponential and also trigonometric. Okay, if you differentiate exponent, so you'll get the same exponent until infinity, right? So you cannot get 0. So what you can do if you have this kind of question? Okay, so all right, so if you have this kind of question, okay, you just you have a table, the same table, which you have the sign. Okay, the sign, second column is something to differentiate and integrate. Okay, and you can use low pad as well. Okay, so we have exponential and trigonometric here. So exponential comes first, so that's why you choose exponential as functions to differentiate. Okay, and cos 2x will be the function to integrate. Okay, so what you need to do is you just perform the 3 iteration only, 3 lines only, or 3 rows only. Okay, okay, you repeat until you get the same. Okay, this one you have cos, right? Okay, you get the same expression, which is cos. Okay, but the net value is not the same, but it comes from the same function, which is cos. So you stop until you get this cos, or you just repeat it until 3 iteration or 3 lines. Okay, you stop. Okay, just now when you put the signs positive, negative, and positive, okay, you need to multiply with the functions to differentiate and integrate, right? Okay, so we have this one, you multiply, okay, the first and second. Okay, this one next is second and third. But for this question, since you cannot get 0 for the differentiation, so you will need to put a new multiplication, okay, between the same rows, which is here, over here. Okay, so this is the arrows that you need to do, okay, so that you can use it to get the final answer. Okay, okay, so this is the table just now. All right, so by adding the products of the entries according to their direction of arrows, taking into consideration the sign positive and negative in the table, so we will obtain, okay, so if you see here, okay, the first one, okay, you have this one, you just multiply as usual, as what we have discussed before. Okay, and then second, you will have this one. Okay, but the last one, okay, so I put this one, so you have the same row, okay, you will have this one, but since it's multiplied with the same rows, you need to put integration. So actually 9 over 4, in the beginning maybe you put in front, in the integral, but you can bring out the negative 9 over 4. Okay, so now what you need to do, okay, since you still have the integration, right? okay, you have the integration, this one. So, but if you see, okay, this is exponent 3x cos 2x. This one also you have exponent 3x cos x. Okay, and both have integral. Okay, it's just the same as if you have 2a plus 3 equal to a. So what you can do, you can bring a to the left. Okay, so you have a equal to negative 3, right? Okay, so same as this integration. So you just bring that negative 9 over 4, okay, into the right left hand side. Okay, so you'll get, this one is 1. So 1, you bring this one in front. So you have 1 plus 9 over 4, which is equal to what? 13 over 4. Okay, so that's why you have 13 over 4. And this one is just the same as what you have previously. Okay, and this one, oh, too many colors here. What color I can use now? Okay, so these two, without having the integral, so you just maintain this one. Okay, so you can just simplify it and bring exponent 3x in front. Okay, right. So at first we want to integrate the question is to integrate exponent 3x cos 2x, right? So what happened to this 13 over 4? So you just need to bring back to the right hand side. Okay, so this will be the final answer. Okay, alright, so this is the answer. I have an exercise for you. Okay, so this is exercise that you need to try to solve this. Okay, so we will discuss this exercise later. Alright, so thank you and see you again. Bye.